Okay, so what we're going to do is we have this problem, cosine theta minus 1 equals 0. And one of the easiest ways to think about this is to draw our unit circle and identify our major coordinates. So remember we're doing xy, so this is 1, 0, this is 0, 1, this is negative 1, 0, and this is 0, negative 1. All right, so now that we've done that, let's go back to our problem. Let's get cosine theta by itself. So cosine theta is going to be equal to 1, right? Because we move that minus 1 over. So what we want to find is where is theta located so that cosine, or the x value, is equal to 0. That's what we're really looking for. So if we go to our unit circle, where is cosine equal to 0? It's equal to 0 up here. It's equal to 0 down here. And those are our two spots. So this is pi over 2. This is 3 pi over 2, right? And so what we're going to do is we're going to label these two spots. So theta is going to be equal to pi over 2, and theta is going to be equal to 3 pi over 2. Now, if we take our pi over 2, this same answer is also accurate if we go around our unit circle all the way around, right? And that's another 2 pi. So what we're going to do is we're going to add 2 pi to this. And because we don't know how many times we want to go around the circle, we're going to use the variable k to show we can go around the circle a bunch of times. And the same thing can be said for our 3 pi over 2. We could also make a circle and go all the way around and do another 2 pi. And we can add k on this as well. And that is going to be our two answers for this problem. So we have this other problem that we want to take a look at, and actually we are going to clean this up just a little bit. It's going to make that minus sign right there. All right, so first things first, we're going to draw this unit circle, label our major coordinates, negative 1, 0, 0, negative 1. All right, let's come back to our problem. So the first thing we're going to do is let's see if we can kind of start cleaning this up. So I'm going to add 1 to both sides. Remember, I changed this to a minus. My apologies for that typo. So we have 2 sine theta squared is equal to 1. Divide both sides by 2. So I have sine squared theta is equal to a half. Okay, and then from here, I am going to take the square root of both sides. So sine theta is going to be equal to plus or minus, right, because you took a square root of the square root of 1/2. All right, so let's take a little closer look at this plus or minus 1/2 situation. First things first, let's deal with the square root of 1/2 thing. So the square root of 1/2 is also the same thing as square root of 1 over the square root of 2. Square root of 1 we know is 1. Square root of 2, now remember, you can't have a radical on the bottom, so we need to simplify it. So we're going to do square root of 2, square root of 2 on the top and the bottom to clean that up. On the bottom, we are going to get square root of 4. On the top, we'll get square root of 2. And square root of 2. So square root of 4 is also the same thing as 2. Now, coming back to that plus or minus that we left out for a little bit, let's come back to that. So what that tells us is that sine theta must be equal to either the positive root 2 over 2, or, let's give that a little bit more space, sine theta must be equal to negative root 2 over 2. All right, so based on this, we now need to add some more data to our unit circle, and that's going to help us figure out what our thetas are. So Root 2 over 2, that has to do with our pi over 4s. There we go. So this is pi over 4. This is 3 pi over 4. This is 5 pi over 4. And over here, 7 pi over 4. All right, so now we can also go through and add our coordinates. So in the first quadrant, everybody's positive, so that's root 2 over 2, root 2 over 2. Sorry, the parentheses kind of cut off. In this quadrant, we have positive y, negative x. So negative root 2 over 2, positive root 2 over 2. Down here in quadrant 3, everybody's negative. Negative root 2 over 2, and then negative root 2 over 2. And in the final quadrant, we have positive x, negative y. All right, so now that we've done that, let's go back. So we're looking for sine theta, which means it's our y value. So we are looking for the first one, positive root 2 over 2. That's over here and over here. And then, so that's going to be pi over 4, 3 pi over 4. And then for negative, as you notice, this has a little bit more answers than the other one. We're looking for negative root 2 over 2. So that's going to be 5 pi over 4 and 7 pi over 4. Now, in the same way that we did the other one, we could go around in a full circle and we could add 2 pi k to each of these. So that would be one version of this answer. The other way to think about it is we could look at pi over 4, and it would be pi over 4 plus pi over 2 gets us to the next one, and then another pi over 2 gets us to the next one, and so forth until we've made a full circle and can continue. The way that would make sense to answer this question is really going to be dependent on what your professor wants, whether they want it so explicit like we did up here, or if this would be the simplified answer that would make more sense. So take a look and think about which one would be correct for you.